Hello friends, welcome to the Data Science and Analytics course. So in this session, we'll start with the introduction to data analytics. Let me give you a quick course overview. In this course, we are going to have three important modules: introduction to data analytics, data science, the data understanding and preparation, and third module is your explainable AI. In the introduction to data analytics, we'll get started with what is data analytics, importance of data in today's world, common data analytics and applications, and the core concepts such as data gathering, cleaning, exploration, and analysis. In the second module, data understanding and preparation, we'll see what are the different data sources and types, such as structured, semi-structured, unstructured. What are the different data collection methods, data cleaning, pre-processing techniques, and the most important thing, the exploratory data analysis. And the third module is your explainable AI. So what makes this course distinct in comparison to the other course is the explainable AI. We'll understand why explainable AI is important, what are the different techniques for explaining model predictions, using some methods such as LIME, SHARP, and few other methods. So we'll apply the explainability to real-world data analytics scenarios. For example, I'm going to say that the customer is going to stop using a service given the probability of 0.9. It's not enough for the business. The business like to get into and understand how is the probability 0.9 has been coming up. I'm going to use some methods like SHARP and LIME, and I'm going to exclusively say that the customer is going to stop using the service because of your poor internet connection, because of the poor network connectivity, because of so and so reasons, given the different attributes that we have considered for the analysis. That's the speciality of the explainable AI. Let's get into the agenda of this session. We'll get started with what is data analytics, importance of data in today's world, 4 stages of data analytics, applications of data analytics, emerging trends in data analytics, and real world examples. I'm going to break this session into 2 different halves and we'll cover what can be covered in the first session. What is data analytics? Data analytics is the process of examining the large data sets to uncover patterns, correlations, trends, and insights. So the data analytics is a multifaceted process. So what is multifaceted if you ask me? I'm going to examine a large data set. Examining in the sense I'm going to discern the patterns, identify the correlations, trends, and insights, or data analytics. It's a wide array of techniques and methodologies aimed at extracting the meaningful information from data to support a decision-making process. There is some data and I'm finding some patterns, correlations, trends, and insights, and I'm making and I'm finding and extracting the meaningful information from the data to support the decision-making processes. The second important point is the statistical and the computational techniques. So the data analytics that we speak about leverages a diverse set of statistical and computational techniques. For example, in descriptive statistics, in regression analysis, machine learning algorithms, your data mining techniques, and NLP as well. So these techniques enables analysts to uncover the hidden relationship between the data, predict the future outcomes, and derive some actionable insights. The third important point is the business optimization and the decision making. So the data analytics is instrumental in helping the business and organizations optimize their operations, improve the decision making processes. So by analyzing the data related to the customer behavior, market trends, and operational performance, I'm going to optimize the process and improve the decision making and gain a competitive edge in the business. So in the today's competitive landscape of business, so this data analytics has emerged as a key differentiator for the business. Companies that effectively harness the power of data analytics can gain a significant competitive advantage by making data-driven decisions that are grounded in empirical evidence rather than intuition or guesswork. Let's take an example. For in retail companies, we are going to use data analytics to optimize the pricing strategies, personalize the marketing campaigns, forecast demand, and outperform the competitors. So, importance of data in today's world. I'm going to show the importance of data using 3 important points: data as a strategic asset, enabling the digital transformation, empowering insights driven cultures. So, what is a data as a strategic asset? So, we spoke about the digital economy. So, in today's digital economy, data has transitioned from a mere byproduct of business operations to a strategic asset driving the innovation and growth. So, what do the organizations need? So, the organizations that effectively harness the power of data gain a competitive edge by making data-driven decisions and can anticipate the market trends and adapt the changing customer preferences. And second important point is enabling the digital transformation. So the importance of data lies in the ability of driving the innovation, improving the efficiency, enhancing the customer experience that we spoke about it a lot. So the data, all in all, we speak about the data is the cornerstone for all the digital transformation that's happening. So the digital transformation that we look at it in today's landscape, which can enable the organizations to digitize the complete process, which can enhance the agility and embrace the innovation. And empowering the insights-driven cultures. So gone are the days we have a shop, we are going to have, we are going to do some marketing and sales is happening. So how can we make use of the data to have an insights-driven cultures? So the proliferation of the data analytics tool has empowered the organizations to foster insights-driven cultures where data-driven decision making is embedded in every aspect of the business. So by democratizing the access to the data and promoting the data literacy to the employees, the organizations can empower teams to leverage data for innovation, problem solving, and continuous improvement. The important point in the introduction that I would like to bring up is the 4 stages of the data analytics. So the data analytics is a structured process. It's a science that unfolds in 4 key stages, each serving a distinct purpose in analytical journey. So understanding these key stages is essential for effectively extracting the insights and making informed decisions based on data. So the 4 stages include your descriptive analytics, what has happened in the past. Diagnostic analytics, why did it happen in the first place? Predictive analytics, what will happen in the future? Prescriptive analytics, how can we make it happen? Now, let's discuss deep about the descriptive analytics. So we say what has happened in the past. So using the descriptive analytics, I'm going to summarize the historical data to gain insights into the past events and trends, which is a foundational understanding of what has happened in the past and serve as the starting point for the future analysis. Let's take an example of an descriptive analytics. I'm going to generate a summary statistics, visualize the data through the charts and graphs, So the two important key things that we spoke is summary statistics and visualizing the data through charts and graphs. When I say in descriptive analytics, two things happen. The summary statistics. So what's an example of a summary statistics? Let's take in a business scenario, the airline passenger ticket booking system. So what is the median number of passengers travel in the month of June? What is the median number of passengers travel in the month of December? Analyze these 2 months. The summary statistics we speak about is the mean, median, mode, and various different formulas involved in it: interquartile range, quartile 1, quartile 2, quartile 3. So we understand the summary in the data, and I'm going to visualize the data using the charts and graphs. Okay, I'm going to create dashboards and monitor the key performance indicators. Therefore, by leveraging the descriptive analytics, organizations can gain valuable insights into the historical patterns, trends, and enable them to identify the areas of improvement and make data-driven decisions. The second thing is your diagnostic analytics. So diagnostic analytics goes beyond your descriptive analytics to understand why certain events has happened. So it focuses on identifying the patterns, anomalies, and correlations in the data to uncover the root causes or the contributing factors. Something has happened. Why did it happen in the first place? There is a spike in the number of passengers traveling in the month of June. We go back and analyze, and we see that there is some festive season that's coming up in the month of June, or that's a holiday season, return back to college scenario where all the students travel back to their natives. Okay, so the key idea here is something has happened, and why did it happen in the first place? So by conducting the diagnostic analytics, the organizations can gain deeper insights into the underlying drivers of the past events or outcomes, enabling them to address the issues more effectively and make informed decisions to prevent the future outcomes. And predictive analytics. So predictive analytics involves the forecasting future. So something has happened. Why did it happen? Given this information, can I do the prediction for the future events? I have the data for the past 12 months. Can I predict using the past data what will happen for the next 1 month? What will be the sales given the same scenario? What will be the number of passengers traveling using the same aircraft, which I have analyzed for the past 12 months of the data. Therefore, predictive analytics involves forecasting future events or outcomes based on the historical events and statistical methods. So examples of predictive analytics include your time series forecasting, regression analysis, and machine learning algorithms such as your decision trees, neural network, and all those things. Prescriptive analytics takes predictive analytics and a step further by recommending actions that can be taken to achieve the desired outcomes. We go to a doctor and we explain to the doctor, I have a cold or a fever, and doctor diagnoses what has happened in the past. Did you eat any ice cream, or something has happened, and a doctor is going to predict, if you don't take medicines, then you will get severely ill, or you will have to get admitted. And the doctor is going to prescribe you medicines. So in similar note, any data scientist should prescribe with the past predictions, with the past data and the future predictions that we have done. So the examples of prescriptive analytics include your optimization models, your simulation techniques, and decision support systems that can recommend an optimal strategies or actions. So by employing the prescriptive analytics, organizations can optimize the decision-making process, improve the operational efficiency, and maximize the business impact by taking proactive steps to achieve and desired outcomes. Thank you. Hello all. Now let's dive into the world of explainable AI or XAI and explore why it's such a critical aspect of AI system. Here, now let's give a quick overview about the course. So now we are in the third module. So we have seen the introduction of data analytics and data understanding and preparation and quick example and case study. And explainable AI. Here we are going to cover why explainable AI is important. What are the different techniques in explaining the model predictions such as Lime, Sharp, and also apply explainability to the real world analytic scenarios. Now what is XAI? So what is exactly an explainable AI? So well, at its core, explainability AI refers to the capability of AI systems to provide understandable explanations for their decisions or predictions. In other words, it's about this demystifying the black box of AI and shedding light on how AI arrives at its conclusions. Now you might be wondering, why is this so important? So the answer lies in fostering the transparency and trust in AI systems. Imagine you're a doctor relying on an AI system for diagnosing in medical conditions, or financial analyst using AI or for risk assessment, or even a passenger in a self-driving car. In each of these scenarios, the ability to understand why the AI made a particular decision or prediction is paramount. It not only instills confidence in the AI capabilities, but also allows the humans to intervene or correct errors when necessary. Now let's consider few examples. To illustrate the importance of explainability, in healthcare, doctors need to trust AI systems for accurate diagnosis and treatment recommendations. However, they need to understand the rationale behind those recommendations to ensure patient safety and well-being. Let's take in world of finance. So accurate risk assessment is crucial for making informed decisions, investment decisions. Without understanding how AI models arrived at their risk predictions, financial analysts may hesitate to trust and act upon those recommendations. In the realm of autonomous driving cars, passengers need to feel confident that self-driving cars are making safe and reliable decisions on the road. So explainable AI provides the transparency needed to build the trust and ensure passenger safety. So explainable AI or XAI plays a vital role in fostering transparency and trust in AI systems across various different domains, from healthcare to finance to transportation. By providing understandable explanations for AI decisions and predictions, XAI empowers users to trust, verify, and ultimately benefit from the capabilities of AI in everyday lives. Importance of XAI. So what's the importance of XAI? The four important pointers to note down is improves the adoption, facilitates decision making, identifies the bias and errors. So the first and foremost, explainable AI enhances trust. By providing transparency in how AI systems arrive at their decisions, XAI or the explainable AI builds trust among users, stakeholders, and other regulatory bodies. When individuals understand the reasoning behind the AI outputs, they are more likely to trust and rely on those systems in various domains. Secondly, explainable AI improves the adoption. So what does improving adoption mean? So when users and organizations can comprehend how AI systems work and why they make certain decisions, they are more inclined to accept and adopt those technologies. So this increased acceptance leads to broader adoption of AI systems, driving innovation and advancement across industries. Next, explainable AI facilitates the decision making. So by offering insights into the rationale behind AI decisions, XAI enables users to make more informed and confident decisions. Whether it's a healthcare professional deciding on a treatment plan, or a business leader making strategic decisions, or understanding AI's reasoning enhances the decision making processes. Lastly, explainable AI identifies the biases and errors. So one of the critical challenge in AI is mitigating biases and errors that can lead to unfair or incorrect outcomes. XAI helps in detecting and addressing these issues by revealing biases, errors, and unintended consequences in AI models. Therefore, by doing so, XAI or explainable AI promotes better model performance or fairness, ensuring equitable outcomes for all. All in all, XAI plays a pivotal role in enhancing trust, improving decision, adoption, and facilitating the decision making and identifying the bias and errors in AI systems. So it's not just about understanding AI outputs. It's about building a foundation of transparency and accountability that fosters trust and drives the responsible AI innovation. Like we have stressed on the importance of enhancing the transparency. Transparency in AI goes beyond providing just the explanations, like we have seen. It's about making the inner working of AI systems accessible and understandable to users. By enhancing the transparency, we empower users to scrutinize and validate AI outputs, fostering accountability and reliability. Transparent AI systems allows users to understand the inner working of AI algorithms, including the data inputs, feature importance, and decision processes. This visibility enables the stakeholders to gain insights into how AI arrives at its conclusions, promoting trust and confidence in the technology. Moreover, interpretability is a crucial aspect of the transparency in AI models. It enables stakeholders to interpret an AI generated insights, making AI more accessible and actionable. When users can interpret and understand AI outputs, they're more likely to trust and act upon those insights in their decision making processes. Therefore, by enhancing the transparency in AI, it's essential for building trust, fostering accountability, and empowering users to make informed decisions. By making the inner workings of AI accessible and interpretable, a transparent AI applications enable stakeholders to validate, trust, and act upon the AI generated insights effectively. The trust, building trust. So the trust in AI and trustworthiness. Trust is the cornerstone of successful AI adoption, and explainability plays a pivotal role in fostering trust among the users and stakeholders. Transparent and explainable AI models instill confidence and reliability by providing the insights into how AI arrives at its decisions. Right? So therefore, when users understand the reasoning behind the AI outputs, they're more likely to trust and rely on those systems in various domains. To illustrate the importance of the trust, let's consider some examples of organizations or industries that prioritize XAI or explainable AI. In healthcare, hospitals and medical institutions use XAI to provide transparent diagnostic recommendations to patients and healthcare professionals. Fostering trust in the accuracy and reliability of AI-driven diagnosis. Let's take a different sector like financial services. Banks and investment firms leverage explainable AI models to provide transparent investment advice to clients, building trust in their integrity and fairness of AI-driven recommendations. So building trust is essential for widespread adoption and success of AI technologies, and explainability is key to achieving the trustworthiness. By prioritizing the explainable AI, organizations can build trust and with customers, regulators, and the public, which could drive confidence and acceptance of AI technologies across various different domains. Now let's see how ensuring accountability and addressing regulatory requirements are so important. Accountability is a fundamental aspect of responsible AI deployment, especially in high stake applications where AI decisions can have significant consequences. Explainability plays a crucial role in ensuring accountability by allowing users to trace and understand the reasoning behind AI outputs. Explainable AI facilitates accountability By providing transparency into the decision making processes of AI systems, users can trace the factors that influenced AI predictions or recommendations, allowing for validation and scrutiny of AI outputs. Furthermore, that there are accountability frameworks and regulations that mandate or encourage the adoption of the explainable AI practices to ensure responsible and ethical AI deployment. Say, for example, healthcare sector, we have regulations such as HIPAA, HIPAA in US and GDPR, in Europe, which require healthcare organizations to provide and transparent explanations for AI-driven diagnosis and treatment recommendations to ensure patient safety and privacy. So, to summarize, ensuring accountability in AI is crucial for promoting transparency, trust, and ethical AI deployment. Explainable AI plays a vital role in facilitating accountability by enabling users to understand and evaluate AI decisions, therefore, thereby promoting the responsible and ethical AI practices across different domains. Now, addressing regulatory requirements. So, what are the different regulatory requirements? So, like I mentioned, there are two major regulatory requirements and compliances. GDPR, the General Data Protection Regulations from the European Union, which mandates the organizations using the AI must provide transparent explanations for AI-driven decisions that impact individuals. On the similarly for financial services, we have our FSB board, Financial Stability Board, and EBA, European Banking Authority, have issued guidelines that require financial institutions to adopt explainable AI practices to ensure compliance with regulatory standards. Right, so therefore, addressing regulatory requirements related to AI explainability is essential for ensuring compliance with regulatory standards and promoting responsible AI deployment. By adopting compliance frameworks and guidelines, organizations can navigate the complex regulatory landscape and build trust in their AI systems. So there are two different explainable AI models, LIME and SHAP. LIME stands for Local Interpretable Model Agnostic Explanations. So LIME is a popular technique used to explain individual predictions of machine learning models. LIME is a powerful, local explanations. So once the synthetic, your synthetic samples are generated, we first, it operates by, by we take the input data around the instance of interest. We are going to create an synthetic samples that are similar to the original instance with a slight variations. Okay, therefore, to link the above statement, once the synthetic samples are generated, LIME fits an interpretable model to them. This interpretable model could be simple linear regression or a decision tree or another interpretable model. The goal is to approximate the behavior of the complex model locally, specifically around the instance of interest. By fitting the interpretable model to unperturbated samples, LIME can provide insights into how individual features contribute to the model's predictions for that particular instance. This granular understanding of feature importance is invaluable for interpreting and understanding the behavior of machine learning models, especially in complex and high dimensional datasets. Therefore, LIME generates local explanations by taking the input data around that instance of interest and fitting an interpretable model to explain the predictions. It provides valuable insights into how individual features contribute to the predictions and making it a valuable tool for understanding model behavior at a granular level. So, LIME is particularly useful for complex models such as deep learning and ensemble methods, which we rather call it as in black box models, where we want each and every model to be interpreted locally, or the instance of prediction, instance of interest. Thank you. Hello, welcome to the module 2 of our data science and analytics course. So the module 2 is all about data understanding and preparation. So before we get started, now let's see where we are in the course overview. So we have completed the module 1, the introduction to data analytics, where we have started with what is data analytics, importance of data in today's world, common data analytics applications, core concepts such as data gathering, cleaning, exploration and analysis. Now, in the second module, we are going to understand what are the different data sources and what are its different types. What is unstructured data? What is semi-structured data? What is an unstructured data? What are the different data collection methods, data cleaning and pre-processing techniques? And we'll also see what is an exploratory data analysis, and I have a small code where we'll discuss each and every steps in an exploratory data analysis. So the agenda of this session is going to be what are the different sources and types, the structured, semi-structured and unstructured, and data collection methods, and data cleaning and pre-processing techniques. Now, what is a data source and what is data types? So understanding the different types of data sources and their respective formats is fundamental in data science and analytics. Now, let's explore the three main types: structured, semi-structured and unstructured data. So what is structured data? So structured data is highly organized and follows a strict schema. So it is typically found in relational databases and spreadsheets. So each data element is organized into rows and columns, making it easy to query and analyze. Let's take some examples in relational databases. It's an example is your SQL database and spreadsheets. So what's in CRM database? In customer information in a CRM database, in transaction records in your financial system, employee details in an HR database, or some examples of unstructured data. So what is semi-structured data? So semi-structured data does not adhere to the rigid schema but has some organization to it. So it often contains metadata or tags to provide additional context. Some common formats for semi-structured data include your JSON format. So the JSON stands for your JavaScript object notation, and your XML files, extensible markup language. So some examples include your JSON files containing your configuration settings. So XML documents describing your hierarchical data structures. Let's also take log files with timestamped entries and key valued pairs. These are some examples of semi-structured data. What is an unstructured data? So unstructured data lacks predefined structure and does not fit neatly into rows and columns. It can include text, images, audio, video, and social media posts. Therefore, analyzing unstructured data requires some specialized techniques such as NLP or natural data storage and management, data analysis and decision making. So where are we going to use the data types? So the properly structuring and organizing data to facilitate efficient storage and retrieval processes. You're going to use that in data storage and management. In data analysis, different types of data require different analysis techniques. Structured data may be analyzed using SQL queries, while unstructured data may require some ML algorithms or machine learning algorithms. Decision making. So accurate interpretation of data depends on the understanding its source and format. Misinterpreting unstructured data as structured, for example, it could lead to incorrect conclusions. So the data comes from various types, each with its own characteristics and challenges. So whether structured, semi-structured, unstructured, understanding the nature of data is essential for effective data management, analysis, and decision making in the field of data science and analysis. Now, Let's get into the important topic, the data collection methods. So I've given three important data collection methods: surveys, web scraping, sensor data collection. So what is data collection and why is it important? So the data collection is the process of gathering information from various sources to be used for analysis, decision making, or research purposes. So let's explore some common data collection methods and considerations for selecting the most appropriate method for your needs. The first method is surveys. What is surveys? So surveys include collecting data through questionnaires, interviews, or polls administered to a sample or respondents. Surveys can be conducted in various formats, including online surveys, telephone surveys, or in-person interviews. Considerations when using surveys include, designing an unbiased question to gather relevant information, ensuring the sample is representative of the population of interest, addressing potential response biases or inaccuracies. The second point is your web scraping. So, the web scraping is an automated extraction of data from websites using some specialized software tools or scripts. So, it allows for large-scale data collection from online sources such as websites, social media platforms, or online databases. Considerations when using in web scraping include, adhering to websites, some terms and services, and legal regulations. These are very important. Some websites will have a lot of legal regulations. Handling dynamic content and website structures. Ensuring data quality and integrity by verifying the scraped data. So these are some considerations when I should be cautious when I'm doing the web scraping. Third important point is sensor data collection. So the sensor data collection involves capturing data from physical sensors or Internet of Things, IoT devices. They like sensors. The sensors, you call it as an IoT devices. The sensors which can measure wide range of parameters, like your temperature, humidity, motion, and much more. So now let's look at what are the important considerations when using the sensor data collection. I need to select the appropriate sensor based on the data requirement. Now ensuring the sensor accuracy and reliability through calibration and maintenance. Now managing large volumes of streaming data generated by sensor in real time. And choosing the right method. What is the right method if you ask me? When selecting a data collection method, it's essential to consider factors such as the data requirement, objectives, resources, and ethical and legal considerations. What specific information do you need to collect and in what format do you need to have? Objectives. What are the goals of the analysis or the research project? Resources. What resources, including time, budget, and expertise, are available for data collection? Ethical and legal considerations. Are there any privacy or compliance issues to address? So data collection methods play a crucial role in acquiring the information needed for the analysis, decision making, and research. By understanding the strengths, limitations, and considerations of different data collection methods, you can effectively gather high quality data to support your objectives in the field of data science and analytics. Data cleaning and pre-processing technique. So the data cleaning and pre-processing are essential step in the data preparation phase of data science and analytics process. So these techniques involve identifying and handling errors, inconsistencies, and missing values in data to ensure its quality and integrity for analysis. Let's explore some common data cleaning and pre-processing techniques. I've given 5 different methods: handling missing values, standardizing data formats, outlier detection and treatment, removing duplicates, encoding categorical variables. So missing values are data points that are absent or unavailable in the dataset. So common techniques for handling missing values include removal. Just delete that record, delete the row or column with missing values. Imputation, replacing missing values with calculated estimate, like you take mean, median, mode. Or you do some prediction, you use some machine learning algorithm to predict the missing values on other features. Consideration when handling missing values include the impact on data integrity and analysis of analysis outcomes, as well as the choice of imputation method based on data distribution on context. Now, removing duplicates. Now, duplicate records are identical rows in the dataset, which can skew the data analysis, which can skew the analysis result and lead to inaccuracies. Now, techniques for removing the duplicates include identifying and removing the duplicate rows based on selected features. There are built-in functions and libraries to detect duplicates. Say for example, if you have used pandas library, pandas.duplicated is a function, predefined function. All we have to do is call that function. It will give us all the duplicate rows or the columns. We can remove it immediately. Now, what are the considerations when removing the duplicates? Right, look at the impact of the analysis. Now, whenever, especially for aggregation or summary statistics, and ensuring an appropriate criteria for identifying the duplicates. Standardizing data formats. Now, standardizing data formats involves ensuring consistency in the representation of data across different features. Techniques for standardizing data formats, including your conversion and your normalization. So what is a conversion? Say for example, I'm converting data into a common format, date format or any unit of measurements. There is one column which has represented, in centimeters, another column which is represented in meters, another column which is represented in millimeters. So I can make it as a same unit of measurement. Okay. So the date format, there are various different formats of date, right? So you can standardize to one single date format. Normalization is another word, scaling the numerical variables to one standard range. There are two common used approaches, or your min-max scaling and z-score normalization. Now, considerations when standardizing the data formats, including enhancing your comparability and interpretability of data, preserving data integrity and preventing the misinterpretation. Now, encoding categorical variables. Now, the categorical variables represent and qualitative data with discrete categories or levels techniques for encoding your categorical variables. So there are two common methods to encode the categorical variables: one-hot encoding and your label encoding. So what is one-hot encoding? I'm going to create a binary columns for each category or dummy variables. You call it as your one-hot encoding. What is your label encoding? I'm converting categories into numerical labels. It's called as an ordinal encoding. Say for example, I have a feedback score in the scale of 1 to 5. So obviously 2 is greater than 1, 3 is greater than 2, 4 is greater than 3, and 5 is greater than 4. So there is some order that's present. So I'm going to do a label encoding here because it's ordinal in nature. I'm going to do one-hot encoding whenever there is, it's a binary column representation. It's nominal in nature. When there is no order in a data set and it's categorical in nature, I'm going to do one-hot encoding. Say for example, pin code, right? I cannot, just by the sake of numbers, I cannot say one number is bigger than the other number because it's a representation of a specificity. So it's nominal in nature. I'm going to do one hot encoding there. So outlier detection and treatment. So whenever there is an outlier, it's very important to treat the outlier and remove the outlier, or you have to treat it in such a way that the outliers are removed from the dataset. So the data cleaning and pre-processing techniques are critical for ensuring the quality, integrity, and reliability of data used for analysis in the field of data science and analytics. So by employing appropriate techniques, data scientists can mitigate errors, inconsistencies, and biases, leading to more accurate and meaningful insights. Thank you. Hi friends, welcome back. So in this session, let's look about the exploratory data analysis, EDA. EDA is a critical step in the data analysis process that involves exploring and understanding the characteristics, patterns, and relationships within the data. Now let's delve into the objectives, techniques, and benefits of EDA. What are the objectives of an EDA? So the objectives of EDA are multifaceted, each contributing to our understanding and interpretation of this data. So all in all, I've given 5 different objectives to understand the distribution and variability of data, identify patterns, trends, and relationship, detect anomalies and outliers, generate hypotheses for further analysis, inform data pre-processing, and feature engineering. So let's understand the distribution and variability of data. So by delving into the distribution and variability of data, we gain insights into the fundamental characteristics. Say for example, let's take a retail sector, understanding the distribution of customer purchase amounts can inform price strategies and promotional campaigns. In similar lines, if I can identify the pattern, trends, and relationships, right? So the EDA empowers us to decipher the intricate of the patterns and trends into our the data fabric. For instance, let's take a healthcare system. So analyzing the patient's medical records can reveal patterns in disease prevalence, or treatment outcomes, and guiding the public health interventions. Third, detecting anomalies and outliers. Anomalies and outliers can often hide the blind it can hide the blind side within our data sets. It's waiting to be uncovered. Let's take in finance sector. So detecting fraudulent transactions amidst millions of legitimate ones can save organizations millions of dollars and preserve trust in the financial systems altogether. The fourth one, generating hypotheses for further analysis. So EDA sparks the curiosity and fuels the imaginations, inspiring us to generate hypotheses and delve deeper into the mysteries of our data. Say for example, in manufacturing, analyzing the equipment sensor data may lead to hypotheses about predictive maintenance strategies, optimizing production efficiency. Now, the last one, informing data pre-processing and feature engineering. So, EDA lays the groundwork for effective data pre-processing and feature engineering, ensuring that our data is refined and optimized for subsequent analysis. In marketing, understanding customer demographics and behavior through EDA can inform feature engineering for targeted marketing campaigns. Now, let's look at various different EDA techniques. What are some EDA techniques that we are aware of? And what are some, why is EDA required? So EDA employs some diverse arrays of techniques to unravel the mysteries concealed within our datasets. Let's delve into the 4 important key techniques of EDA and explore how they are applied in various industries. So the 4 techniques that I have taken here is summary statistics, data visualizations, correlation analysis, dimensionality reduction. So if I start speaking about EDA, there are hundreds of techniques. Let's start with the first and important things. Summary statistics. So summary statistics serve as the foundational pillar upon which our understanding of the data is built. Descriptive measures such as mean, median, mode, variance, and standard deviation provide us the invaluable insight into the central tendency and variability of our data. Let's take, for example, in finance, in summary statistics plays a pivotal role in risk assessment and portfolio management. Calculating the mean return and standard deviation of assets allows the investors to gauge their investment performance and assess the level of risk associated with their portfolio. I have a portfolio. What is the investment performance in the stocks that I have invested? What is the level of risk that's associated within the portfolio? All this comes under the summary statistics. Second is data visualization. So data visualization transforms the raw numbers into captivating visual narratives, enabling us to perceive patterns, trends, and relationships that may remain hidden in the tabular form. Now, techniques such as histogram, box plot, scatter plot, and heat map, the four important techniques: histogram, box plot, scatter plot, and also the heat maps. So offer a visual canvas upon which the data distribution, relationships, and patterns are painted on. Let's take an industry example so that you can understand and relate to each other. So in marketing, data visualization is a powerful tool for understanding customer behavior and preferences. Visualizing the customer demographics through demographics, histograms, or exploring the relationship between the advertising expenditure and sales using the scatter plots can inform targeted marketing strategies and campaign optimization efforts. Third one, correlation analysis. Correlation analysis quantifies the strength and direction of relationship between variables, illuminating the intricate web of connections woven into our data. Now, some measures such as your Pearson correlation coefficient, your Spearman rank correlation, and covariance, all this provides us with the numerical insights into the interplay between the variables. Now let's take an industry example. In healthcare industry, the correlation analysis is instrumental in uncovering the relationships between the medical variables and patient outcomes. Analyzing the correlation, between the lifestyle factors such as diet and exercise and health outcomes such as blood pressure, cholesterol levels, can inform preventive and healthcare interventions and personalized treatment plans. The fourth important EDA technique is your dimensionality reduction. So once you get into your ML and data mining sessions, so there is a term called as a curse of dimensionality. So the more the dimensions, more the problems. So what is more the dimensions? So I could do a prediction of one use case using various different attributes. So each and every attribute is called as a dimension. I can predict whether a person will get a heart attack or he will not get a heart attack using attributes such as whether how much cigarettes he had smoked, whether he is an alcoholic, whether the person is has high BP, what is the cholesterol level, what is his lifestyle attributes, right? So these are all various different attributes vis-a-vis dimensions. So ideally, any machine learning algorithm should have less dimensions to do and better predictions. So dimensionality reductions such as your principal component analysis, PCA, you do an orthogonal rotation in PCA, and TSNE, T distributed stochastic neighbor embedding, offers a gateway to the realm of high dimension data, allowing us to navigate the intricate landscape of features and variables with ease. Let's take an industry example. In manufacturing, dimensionality reduction techniques are employed to streamline the production process and optimize the product quality. So using PCA to identify the principal components of the product specifications and TSNE to visualize the clustering of the product defects can inform quality control measures and process improvements. All in all, to conclude the techniques of EDA, so it serves as the compass that guides us through the where the data. It can illuminate the path to discovery and insight. By leveraging the summary statistics, data visualization, correlation analysis, and dimensionality reduction techniques, we unlock the hidden treasures concealed within our data sets and pave the way for informed decision making and innovation in myriad of industries. Now, we have started with what is EDA and what are the different objectives of EDA and EDA techniques. Now, let's see what are the benefits of an exploratory data analysis. So, EDA is not merely a preliminary step in the data analysis process. It is the key that unlocks the door to a treasure trove of insights buried within our data sets. Now, let's explore the myriad of benefits of EDA that offers, along with some industry examples that can illustrate your real world impact. The first one is insight generation. So EDA serves as the beacon that illuminates the dark concerns of our data, revealing hidden insights and patterns that may otherwise remain obscured. By peeling back the layers of the complexity, EDA provides us with deeper understanding and underlying phenomena. Let's take an example, industry example. In retail, EDA can reveal valuable insights into customer purchasing behavior. Analyzing sales data may uncover seasonal trends, purchasing patterns, and correlation between the product categories, empowering retailers to optimize the inventory management and tailor the marketing strategies to the customer preferences. The second one is your anomaly detection. EDA acts as a guardian of data integrity, alerting us to anomalies and outliers that may signify the data errors or the noteworthy occurrences. By identifying these arbitrations, EDA enables us to investigate further, and and it can glean the valuable insights from the unexpected occurrences. So what does it mean? Anomaly detection. In cyber security, EDA plays an critical role in detecting the anomalous network behavior. It can be indicative of various potential cyber threats. Analyzing network traffic data may reveal unusual patterns or spikes in activity. By promoting immediate investigation and mitigation to safeguard against various different cyber attacks that we have. Let's take the third important benefit of an EDA, your hypothesis generation. Now, what is hypothesis generation? So EDA sparks the curiosity and fuels the imagination and inspiring us to generate hypotheses and delve deeper into the mysteries of our data. By exploring patterns and relationships, EDA provides us with a fertile ground from which hypotheses emerge, guiding further analysis and experimentation. So in healthcare, EDA can lead to formulation of hypotheses about disease prevalence and risk factors. Analyzing patients' medical records may reveal correlations between demographic factors, lifestyle choices, and disease outcomes, guiding public health interventions and clinical research studies. The last point is communicate findings to the stakeholders effectively. So whatever that we have found in the data, by doing an effective exploratory data analysis, you can communicate in terms of the summary statistics and visual aid to the end users or the stakeholders in an effective manner. So in conclusion, exploratory data analysis is a powerful tool for uncovering the insights, detecting anomalies, generating hypothesis, and it can even guide the data pre-processing decisions. By leveraging EDA techniques, the data scientist can gain deeper insights of their data, identify the key trends and relationships, and drive data-driven decision-making process across the wide range of industries. In the next session, let's take in sample data and do the exploratory data analysis of what we have what we have seen so far. We'll start with the descriptive statistics, and we'll also descriptive analytics, and we'll do the basic summary statistics and see what is present in the data and what can be done to treat the data. Thank you. Hi friends, welcome back. So in this session, let's see how one data analytics can help businesses. So the data analytics finds applications across various industries and business functions, enabling the organizations to improve the operational efficiency, enhance the customer experience, drive innovation, and mitigate risks. So what does improving operational efficiency for a business mean? By analyzing the operational data, organizations can identify inefficiencies, streamline processes, and optimize resource allocation to improve the overall efficiency and reduce the costs. Enhancing the customer experiences. So the data analytics enables organization to understand the customer preferences, customers' behavior, customers' needs, and allowing them to deliver personalized experiences, targeted marketing campaigns, and tailored product offerings. And what doesn't drive innovation? So the data analytics fuels the innovation by providing insights into market trends, customer demands, and emerging technologies. So by analyzing the market data, consumer feedback, and as an organization, they can identify the new opportunities, untapped opportunities in the market, and develop innovative products and services to meet evolving customer needs. Mitigate risks. So this predictive analytics helps organizations identify potential risks and anticipate the future events, enable them to take proactive measures to mitigate risks, prevent losses, and protect their business interests. Now, saying this, what are the various different challenges and considerations that we have? So the data analytics offers numerous opportunities. Organizations must also navigate the challenges such as the data privacy concerns, security risks, and the most important thing is the ethical consideration. So it's essential for the organizations to establish robust data governance frameworks, adhere to the regulatory requirements, prioritize the data security and privacy to build trust with the stakeholders and mitigate the risks. And next, coming to the emerging trends in data analytics. So the emerging trends in data analytics. So let's take few examples or case studies in industries and understand what are the different emerging trends in the data analytics. Let's take 4 important top sectors: banking, supply chain, e-commerce, travel and hospitality. We'll also discuss various different industries in forthcoming sessions. So let's start with banking. So, and real-time fraud detection is an example, very famous example. Fraud detection, the number one use case in banking. So the banks utilize advanced analytical techniques to monitor transactions in real time and identify suspicious activities such as unusual spending patterns and unauthorized access to prevent to fraudulent and transactions before they even occur. Let's take a different sector, supply chain. So what does a supply chain industry do for us? A famous example is your real-time inventory management. So how can I use the data analytics in supply chain to do the real-time inventory management? So supply chain companies leverage real-time analytics to monitor the inventory levels, to track the shipments, optimize the warehouse operations. The most important thing, optimizing the warehouse operations. So by analyzing the real-time data from sensors, IoT devices, they can ensure efficient inventory management and minimize the stockouts or overstock situations. Another example is your e-commerce company. We can come up with personalized recommendations. Personalized recommendations. So e-commerce platforms use real-time analytics to analyze the user behavior, browsing history, and purchase patterns to deliver personalized product recommendations in real time. We can use machine learning algorithms. They can tailor recommendations to individual preferences and can increase the conversion rates and customer satisfaction. Last application that we would like to see here is travel and hospitality. A famous example is your dynamic pricing. We have seen often that we like to book a ticket today, which drastically changes from the amount that we have seen yesterday. Again, I procrastinate and I would like to book the ticket tomorrow. We can see that there is a flight. The price fluctuation could have either been increased or decreased. So how do these companies do? They're going to use something called as a dynamic pricing. So the travel and hospitality companies employ in real-time analytics to adjust the prices dynamically based on demand, competitor pricing, and other market factors. So by analyzing the real-time data on booking trends, customer preferences, and market dynamics, they can optimize the pricing strategies to maximize the revenue and the company rates. These are some emerging trends I would like to I have taken 4 different sectors. We could speak about this for hours together, but just for to give an overview, we have taken this 4 different sectors and 4 examples where we can use an analytics to do and business optimization, which can help the business to optimize their existing business operations. Real world examples. Let's take some real world examples here. Are Uber, Netflix, and healthcare industry. We have seen sector wise. Now let's take real-time companies and see how the Uber is making use of data analytics. Uber is highly relies on the data analytics to optimize its ride sharing platform, improve the driver allocation, and enhance the overall experience. Through real-time data analysis, Uber can predict the riders' demand in specific areas and adjust the pricing dynamically and minimize the wait times for the passengers. The other example is your Netflix. So the Netflix recommend personalized content to its subscribers based on their viewing history and preferences. So the Netflix uses the data analytics to recommend and personalized content to its subscribers based on the viewing history. Famous example is your recommendation system. By analyzing the vast amounts of viewers' data, Netflix can accurately predict what shows or movies a user is likely to enjoy, which can lead to a higher user engagement and customer satisfaction. Healthcare industry. In the healthcare sector, data analytics is used to analyze the patient data, predict the disease outbreaks, optimize the treatment plans, and improve the patient outcomes. For instance, predictive analytics can help the healthcare providers identify patients at risks of developing chronic conditions, which can allow for early intervention and preventive care measures. Therefore, by leveraging the data analytics efficiently and effectively, organizations can, across various industries, can gain valuable insights into their operations, customers, and markets, which can enable them to stay ahead of the competition and drive the innovation. Now that we have seen some various different examples, applications in real time, now let's see the core concepts. There are 4 important core concepts. Starts from the data gathering, data cleaning, data exploration, and data analysis. Now let's see each of them in detail in the forthcoming sessions. Now let's see what is a data gathering altogether. So the data gathering serves as a foundational stage of the data analytics process. I need data. First of all, when I speak about data science, data analytics, I need data. So the data involves, it involves collecting data from various different sources such as database, APIs, sensors, surveys, or in the form of videos, photos, whatever manner let it be. I need data. So the data gathering is the first and foremost important step. The quality and the relevance of the gathered data. So it's not that just that I have 12 years of data. I have gathered so much of video data. I have captured so much of information, the tabular data from the databases. The quality and the relevance of the gathered data, directly impact the accuracy and reliability of the subsequent analysis that we are going to do. Let's take an example. In retail, the data gathering is the most important thing in the 4-step analytical process that we spoke about earlier. So in retail, data gathering involves collecting customer transaction data to understand purchasing behavior and preferences. Similarly, in manufacturing, sensor data might be collected to monitor equipment and performance, equipment performance and detect anomalies in real time. The second step here is the data cleaning process. So once the data is gathered, it needs to be prepared for analysis through data cleaning stage. So preparing the gathered data for analysis by identifying and correcting errors, inconsistencies, and missing values is what we do in the data cleaning process. So the data cleaning is also known as the data pre-processing, which involves identifying and correcting errors, inconsistencies, and missing values. The common tasks in the data cleaning include removing duplicate values, handling missing values, standardizing various different formats. So let's take an image data. Say if you want to do a convolution neural network or any image processing, if the photo is of various different pixel sizes, I need to standardize the pixel formats. Or if the data, let's take 2 different data, age and salary, or years of experience and salary. If I'm going to do some modeling, I need to normalize the data. 10 years of experience and 1 lakh salary. right? So the 10 is 2 digits and 1 lakh is 6 digits. I need to standardize, I need to normalize the data between a range of -1 to +1 or 0 to 1. And there are various different standardizing formats that we'll discuss later on. And correcting inaccuracies. So that is what we'll be doing in data cleaning or the data pre-processing. Let's take an example. In finance, the data cleaning might involve reconciling discrepancies in the financial records or identifying and removing the outliers from the data sets to ensure accuracy in financial analysis. In data exploration, the third important core concept here is the data exploration. I have the data collected, I have the data cleaned and prepared. Now we move on to the data exploration stage. Data exploration involves exploring and visualizing the clean data to gain insights into the characteristics and patterns and relationships. In EDA, we spoke about EDA a lot, exploratory data analysis techniques such as your summary statistics, data visualization, correlation analysis are used to uncover the insights and to identify trends. So it's more about exploring and visualizing the clean data to gain insights into the characteristics and patterns and relationships. Now let's take an example. In marketing, data exploration might involve analyzing the customer demographics and purchase behavior to identify the target market segments and tailor the marketing campaigns accordingly. Now, the fourth step, the fourth core concept here is your data analysis. We arrive at the data analysis stage where advanced techniques such as your statistical analysis, machine learning, and regressions are applied to extract the meaningful insights from the data. Data analysis involves such as your predictive modeling, clustering, classification, and hypothesis testing to derive insights and support decision making. Let's take an example of healthcare. Data analysis might involve predicting patients' outcome based on the medical history and diagnostic tests, tests enabling the healthcare providers to personalize treatment plan and improve the patient care. These are the 4 important core concepts that we'll be discussing in the forthcoming sessions. Thank you. Like we have seen earlier, LIME is a powerful technique for generating local explanations for machine learning model predictions. Now let's see, how does a LIME model work? So the LIME, or the local interpretation model agnostic explanations, works to provide local explanations for the machine learning model predictions. How does the LIME operate? It operates by creating the instances of interest, essentially generating synthetic samples that are similar to the original instance but with slight variations. This help in understanding how the model predictions change with the changes in the input features. Once the synthetic samples are generated, LIME fits an interpretable model to them. This interpretable model could be a simple regression, a decision tree, or another interpretable model. The goal is to approximate the behavior of the complex model locally, specifically around the instance of interest. By fitting the interpretable model to the samples, LIME can provide insights into how each feature contributes to the model's prediction for that particular instance. The coefficients of the interpretable model indicate the importance of each feature in influencing the prediction. Positive coefficients indicate that positively contribute to the prediction. On the contrary, negative coefficients suggest that the features have a negative impact. In summary, LIME works by generating synthetic samples around the instance of interest, fitting an interpretable model to the samples, and using the coefficients of the interpretable model to understand the importance of each feature in prediction for that instance. This approach enables us to gain insights into the inner workings of the complex machine learning models at a local level, enhancing our understanding and trust in their predictions. Now, let's see what a SHAP model does. SHAP is otherwise called as Shapley Additive Explanations, SHAP, S-H-A-P. SHAP is a powerful technique that offers a unified framework for interpreting the output of any machine learning model, regardless of its complexity or type. It provides a comprehensive understanding of feature importance and contribution to model predictions. One of the key strengths of SHAP is its ability to assign each feature an importance value based on its contribution to the prediction. Unlike some other techniques, SHAP considers all possible combinations of features, providing a more holistic view of feature importances. By considering the interactions between the features and their impact on predictions, SHAP offers deeper insights into underlying relationship within the data. The level of this granularity enables the stakeholders to make more informed decisions and gain a better understanding of how the model arrives at its predictions. SHAP's unified framework and feature important values make it valuable tool for interpreting and explaining machine learning models across various domains and applications. Whether it's understanding the factors driving customer behavior in marketing or identifying key variables influencing patient outcomes in healthcare, SHAP provides actionable incomes that drive decision making. So, all in all, SHAP offers a unified framework for interpreting model predictions and assigns each feature an importance value based on its contribution to the prediction. By considering all the possible combinations of features, SHAP provides comprehensive insights into model behavior and enhances our understanding of complex machine learning models. Now, we'll explore how does SHAP work. Right, so SHAP values are powerful tool, to understand the impact of the individual features on the model output. So they measure the contribution of each feature by considering all the possible subset of features in the dataset. Okay, so the calculation of SHAP value involves comparing the model's predictions with and without the features of interest. This comparison is made by every possible combinations of features, resulting in a comprehensive assessment of each feature's importance. The key concept behind SHAP values is to quantify the difference in model predictions when a particular feature is included or excluded. By averaging over all possible feature combinations, SHAP values provide a robust measure of feature importance that accounts for interaction between features. Positive SHAP values indicate that they contribute positively to the model's predictions, meaning that the presence increases the output of the model. On the other hand, negative SHAP value suggests the features of a negative impact on that prediction, leading to a decrease in the model's output. By interpreting the SHAP values, stakeholders can gain valuable insights into factors driving model predictions and understanding the relative importance of different features in influencing the outcomes. This level of understanding enhances the interpretability and trustworthiness of machine learning models, empowering users to make more informed decisions. So, in summary, SHAP works by measuring the impact of each feature on the model's output, considering all possible subset of features. Positive SHAP values indicate features that contribute positively to the prediction, while negative values indicate features that have a negative impact, providing valuable insights to the model behavior and features importance. So let's compare between LIME and SHAP. So what is LIME and SHAP we have seen so far? Let's take a few differences. Model specific versus model agnostic. Global versus local explanations, and what is the complexity? So model specific versus model agnostic. SHAP is a model specific and requires access to the internals of the model, while the LIME is some model agnostic. It can be applied to any black box model without knowledge of its internals. SHAP Sharp explanations are tailored to specific model, okay, which can require access to its internal structure. This allows Sharp to provide insights directly relevant to the model's decision making process. What happens for the Lime? Lime, on the contrary, does not rely on the internals of the models being explained. It operates independently of the model's architecture, making it applicable to any black box model. So, this model agnostic nature of Lime makes it more versatile and widely applicable across different machine learning models. The second important point here is global versus local explanations. Sharp provides both global and local explanations, whereas Lime primarily focuses on the local explanations. So, what is a global versus local explanation? At a high level, the complete data, which are the driving factors, which is giving this final conclusions or the predictions. That is what you call it as a global explanation. Local explanation, on the other hand, for each and every record, what is the contributing attribute? Why is the prediction being done is either positive or negative is given by these local explanations. So Sharp offers insights at both global and local levels. So global explanations help in understanding the overall model behavior and feature importance across the entire data set. If I speak about the entire data set, are called as the global explanations. Local explanations zoom into the individual predictions, like I mentioned, which could provide insights into why a particular prediction was made for a specific instance. Let's take, for example, if I have said that the customer has been rejected to get the loan, at a specific instance is called as the local explanations. What are the driving attributes? You give it as the local explanations. Lime predominantly focuses on providing the local explanations. It aims to explain individual predictions by approximating the behavior of the black box model around specific instances. While global insights are not directly provided by Lime, it can still offer valuable insights into local decision making processes. So, this is more of local interpretation. On the other hand, Sharp can give both a global and a local interpretation. However, even if you're going to use a Lime, so from the model, whatever the model I'm going to use, I can still get the global interpretations from that model itself, the feature importances. But not using this method, but using that specific ML models method. Now look at the complexity. What's the complexity? Sharp tends to be computationally more intensive due to its reliance on the Shapley values. Whatever the values that are generated by Sharp, you call it as the Shapley values. While Lime is computationally less intensive, but may sacrifice some accuracy for simplicity. Now, Sharp's computation involves calculating the Shapley values, which can be computationally demanding, especially for complex models and large data sets. So, this computationally intensify may limit the scalability of Sharp for very large data set or models with high complexity. Lime being computationally less intensive compared to Sharp, which uses some simple interpretable models such as linear models to approximate the behavior of the black box model. While Lime may sacrifice more accuracy for simplicity, its computational efficiency makes it more suitable for quick prototyping and interpretation tasks. So this is a high-level comparison between Lime and then Sharp. We can see that the important points to note here is the complexity. The complexity here is a driving factor. It's more computationally more intensive here. Here it is less intensive. However, Lime can give local explanations only. Sharp can give both global and local explanations. So before you pick a specific model agnostic method and Sharp or Lime, go to the business, the necessity, and finalize whether you're going to pick a Lime model or a Sharp model. Let's come to the use cases of Lime and Sharp. What are the different use cases that where we can use in Lime and Sharp? Let's take in finance. Or let's start with an healthcare. In healthcare, you can see an disease diagnosis. Okay, let's take an example of a disease diagnosis. So, medical institutions utilize ML models for disease diagnosis based on patients' data. So, the SHARP is used to interpret model predictions, offering explanations for individual diagnosis. Okay, so the clinicians can leverage these insights to validate the model decisions and tailor treatment plans accordingly. Now, also let's take an an finance domain. An example, let's take an credit scoring, in famous example. And bank uses ML models to assess credit worthiness of the loan applications. So SHARP is employed to explain individual credit decisions, providing insights into the factors contributing to loan approvals or denials. This helps the bank understand the model's behavior and ensure fair lending practices. Now, let's take an e-commerce and product recommendation. Okay, an online a retailer employs some complex recommendation systems to suggest products to users. So Lime is utilized to provide explanations for specific product recommendations, enable users to understand why certain items are suggested to them. This enhances the user trust and engagement with the recommendation system. The last is your marketing. Let's take an example of a customer segmentation. So the use case here goes like this. The marketing team leverage ML models to segment customers based on their purchasing behavior. So the application Lime is applied to explain why certain customers are grouped together in specific segments. This helps marketers understand the characteristics of the driving segmentation decisions and tailor marketing strategies accordingly. So these are different use cases of Lime and Sharp. So we have started with the two different, the famous models Lime and Sharp, and we have seen how a Lime works and how a Sharp works, and the comparison between Lime model and Sharp model, and the different use cases of Lime and Sharp model. Thank you.